Question 1 from the SAT. The data in the table above were produced by a sleep researcher, studying the number of dreams people recall when asked to record their dreams for 1 week. Group X consisted of 100 people who observed early bedtimes, and Group Y consisted of 100 people who observed later bedtimes. If a person is chosen at random from those who recalled at least one dream, what's the probability that the person belonged to Group Y? This is the conditional probability type of question. Let's read the actual question part. If a person is chosen at random from those who recalled at least one dream, that's the condition that we're being given. What's the probability that that person belonged to Group Y? So let's examine this table. We have Group X in the first row, Group Y in the second row, the totals over here. And then the people who didn't recall any dreams in this first column, people who recalled 1 to 4 dreams here, people who recalled 5 or more dreams, and the totals is the last column. So as we recall, probability can be found by, figuring out the numerator, which is the favorable outcome over the total possible. So let's examine this one more time. A person is chosen at random from those who recalled at least one dream. So which group of people recalled at least one dream? It's got to be these. 1 to 4 dreams was 39, and 5 or more was 125. So that's the grand total of the people who recalled at least one dream. So that means our denominator is going to be 39 plus 125. And then the restriction that we were given is that those people have to come from Group Y. So that is 11 and 68 combined. And that's going to be our numerator, 11 plus 68. So quick arithmetic will make sure that you get a 79 over 164, which makes C the correct answer to this question. Here's another two-way frequency table. A group of 10th grade students responded to a survey that asked which math course they were currently enrolled in. The survey data were broken down as shown in the table above. Which of the following categories accounts for approximately 19% of all survey respondents? So which of the following categories accounts for approximately 19% of all surveyed respondents? Once again, this is a two-way frequency table. Real quick, we have gender, which is male or female, and a grand total. And then as far as columns are concerned, the topics are Algebra 1, Geometry, Algebra 2, and the grand total. So this is slightly different in that we're not looking for a number answer, right? We're given the percent, we're given the ratio. And I think the best way to approach this is just look at each choice one by one and determine if it makes sense or not. So the probability for females taking geometry is 53 out of 310. And thankfully, this is the calculator portion. So you are allowed to use a calculator. And if you plug this in, you will have around 17%. So that's not quite 19. It's pretty close because they're saying approximately. So let's look at all the other ones. Females taking Algebra 2 would be 62 out of 310. And if you punch that into the calculator, you will end up with a 20%. Let's keep plugging these in. Males taking geometry. Males in geometry is 59 out of 310. And that gives us approximately 19%. So that could very well be it. And last but not least, males taking Algebra 1 would be 44 over 310, which gives us approximately 14%. So yeah, we wanted around 19%, and that came from C. So C would have to be the answer to this question. Next question is from the ACT probability question. The blood types of 150 people were determined for a study as shown in the figure below. So on the x-axis, we have blood type, either O, A, B, or AB. And on the y-axis, we have the number of people. So now for the question, if one person from this study is randomly selected, what is the probability that this person has either type A or type AB? So this is an or probability. So remember what we said. We want A or AB. And we found that these OR probabilities have a formula. And we saw the formula is A plus the other event, which is AB. And then you always want to subtract the overlap, which is having both A and AB. So let's actually put this into practice. We have probability of A. How many people have blood type A is 67 of a possible 150. Plus, How many people have blood type AB? 6 over 150. And then we're going to subtract the overlap. Is it possible to have blood type A and at the same time have blood type AB? That is impossible. You can't have both types of blood. You have to either have A or B. So seeing that there is no overlap, we don't need this last part. So you can always make that determination by reading the question carefully and seeing if it makes sense to subtract an overlap if you have one. So quick arithmetic, 67 plus 6 is 73 over 150, which makes D the answer to this question.